Okay, pre-calc, we are going to do 5.3, trigonometric functions of acute angles. And I'm on 5.1, so hold on a minute. Here we go. Page 4 of your notes. Okay, so what we're going to do now is put our angles inside triangles, specifically right triangles. Now you already know 3 trigonometric functions. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. We always want to use these on an acute angle. And we memorize so, which is sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. But now we are going to learn 3 more trig ratios, and these are the reciprocal ratios. So we have for that cosecant, secant, and cotangent. And keep in mind these are the reciprocal ratios, not inverse ratios. Inverse, remember the inverse, let's go back up here. The inverse of sine, like if I have sine theta equals, 1, then we would say the inverse sine of 1 is theta. The inverse is how we find that angle measure. All right? So inverse ratios are here. We have cosine inverse, and we have tangent inverse. So these are inverse. They are different than reciprocals. All right? By the way, another word that you're going to learn in a couple of units for inverse is arc. So we could say arc sine. Arc sine is the same as sine to the negative 1. And arc cosine is the same as cosine to the negative 1. And arc tangent is the same as tangent to the negative 1. So these are all your inverse ratios. But these that we're going to learn today are our reciprocal ratios. All right, so here is your definition. A cosecant is the reciprocal of sine. So basically, if sine of theta is opposite over hypotenuse, then cosecant of theta is hypotenuse over opposite. Secant is 1 over cosine. So if cosine of theta is adjacent over hypotenuse, then secant of theta is hypotenuse over adjacent. And then finally, cotangent is 1 over tangent. So therefore, if tangent of theta is opposite over adjacent, then cotangent of theta is adjacent over opposite. And so there are your 6 trig ratios. And example 1. Using the triangle at the right, find all 6 trig functions of the angle theta. So the first thing you want to do is you notice that this side length is missing. So we are going to find that, and we will call that y. So I will say y squared plus 21 squared equals 29 squared. So y squared, doing a little math here, is going to give me 400, and y is 20. By the way, there is something called a Pythagorean triplet. These are 3 sides of a right triangle that satisfy Pythagorean theorem. So like a 3, 4, 5 triangle. Your hypotenuse would be 5. The 2 legs are 3 and 4. And of course we know 3 squared plus 4 squared equals 5 squared. So this is called a Pythagorean triplet right here. Any why am I not drawing? Okay, hold on. pen is not working. Hold on, you guys. Okay, I think we're working now. But any multiple of these three numbers are also a Pythagorean triplet. For example, if I multiply them all by 2, I have a 6, 8, 10 Pythagorean triplet. By 3, I would have a 9, 12, 15. These are all Pythagorean triplets. So if you memorize this base triplet, then if you had like two numbers, 12 and 15, like 15 is your hypotenuse, 12 is a leg, then you know this has to be 9. These have to go together. So another Pythagorean triplet is right here. We have 20, 21, 29. That's a Pythagorean triplet. We're going to run across a couple more as we go through this. Well, here I can give you another one right now. 5, 12, 13. That's a Pythagorean triplet. So if you know two of those sides, the hypotenuse has to be 13. The two legs are 5 and 12, which also means then, of course, that 10, 24, 26 is a Pythagorean triplet. Anyhow, okay. Moving back to the problem. Sorry, I got a little distracted. So we found our third side, which is 20. And now we're going to find all our trig functions. Here's our theta over here. And so we will say the sine of theta is opposite over hypotenuse, 20 over 29. The cosine of theta is adjacent over hypotenuse, 21 over 29. The tangent of theta is opposite over adjacent, 20 over 21. Next, cosecant of theta. Remember, cosecant is the opposite of sine. So each one of these have a co in it. Like this little couple right here, sine and cosecant, it has one co. Cosine and secant have one co in it, and then tangent and cotangent have one co. So obviously, no one ever forgets that tangent and cotangent are reciprocals of each other. But frequently we forget secant and cosecant, or I'm sorry, secant and cosine are reciprocals, but they are. So just remember, since cosine already has a co, this has to be the secant here. And since sine doesn't have a co, it has to be cosecant that goes with it. I don't know if that makes sense, but I don't know, works for me. All right, cosecant is hypotenuse over opposite, so we have 29 over 20. It is also simply the reciprocal of sine. Secant of theta is 29 over 21, the reciprocal of cosine, and also hypotenuse over adjacent. And cotangent is 21 over 20, the reciprocal of tangent, and also adjacent over opposite. All right, example 2. Having a few issues here. Not sure why. Why am I shrinking rather than moving? Try it that way. Okay. This time, we are given that tangent of theta is 5 over 12. Find the remaining trig functions. So right now, we are just working in triangles. We're not working on the unit circle, if you remember that from Algebra 2. But, so we're just going to draw a triangle here. It has to be a right triangle. So there you go. Theta is either one of these angles. And tangent, remember, tangent of theta is opposite over adjacent. So opposite is 5, adjacent is 12. All right, so here we have a right triangle. One side is 5, one side is 12. You can use Pythagoras, and you can call this, you know, whatever you want. We'll call it C. You can use Pythagoras and say C squared equals 12 squared plus 5 squared, and you can proceed to do the work, and you'll get C equals 13. Or you can refer up here to this Pythagorean triplet right there. And this Pythagorean triplet says that if one leg is 5 and another leg is 5, the hypotenuse has to be 13, and that fits into this. So we know, either using Pythagorean theorem or using Pythagorean triplets, that C has to be 13. So once we know that, we can find all the rest of our trig functions. So we have sine of theta is opposite over hypotenuse, 5, 13. Cosine of theta is adjacent over hypotenuse, which is 12 over 13. We have cotangent of theta. That's really easy because we already were given that, 12 over 5. We have cosecant of theta, which is the reciprocal of sine, which is 13 over 5. And then we have secant of theta, which is the inverse of cosine, I'm sorry, not the inverse, the reciprocal of cosine, which is 13 over 12. We'll try this again. And we are still shrinking. Hold on. All right, hopefully that will work. So now we are on page 2, special right triangles, everyone's favorite. Hopefully you already have memorized these, so this shouldn't be too bad. So number 1, 45, 45, 90 right triangle. So this is an isosceles right triangle. And maybe if I use, oh, perfect. Okay. Isosceles right triangle, we have two 45-degree angles. So here's 45 and here's your 45. These legs are equal. If AC is 1 and the measure of angle A is 45, solve for the remaining parts of the triangle. So this first problem says AC is 1, which is my hypotenuse, right? Hypotenuse is 1. So therefore, my two legs have to be equal, so we'll just call them, oh, I'm sorry, AC is not the hypotenuse, much better. AC is 1, that means BC is 1, and this is my hypotenuse. Let's find that. So I'm going to say 1 squared plus 1 squared equals AB squared. That's the Pythagorean theorem. So AB squared equals 2, and AB is the square root of 2. And this is your special 45, 45, 90 right triangle. And you need to memorize that. These sides are 1s, and this is the square root of 2. Okay? Now let's find the six-fig trig functions for 45. So we'll do sine of 45-degree angle is opposite. These angles are equal, so it doesn't matter which one you use. Opposite over hypotenuse, 1 over radical 2. Cosine of a 45-degree angle is also 1 over radical 2. Tangent of a 45-degree angle is 1. Opposite over adjacent. Cosecant of a 45-degree angle is going to be radical 2 over 1. Secant of a 45-degree angle is going to be radical 2 over 1, and cotangent of a 45-degree angle is 1. It is recommended that you memorize these. It is required that you memorize this, that you can draw. If you can draw this 45, 45, 90 right triangle with 1, 1, and radical 2, then you can always find these. If you don't memorize these, it's okay, because you can sketch this and find these. And over the course of my life, I think when I was in college, I had all these memorized because I use them so frequently. But it's just been a year or two since I graduated from college, and I've forgotten some of those. And so I always, though, can draw this right triangle and find this information. Number 2, special right triangle, is the 30, 60, 90 right triangle. So, triangle ABC right here is equilateral. So each angle is 60 degrees. This is an equilateral triangle. We can mark it up. Draw the altitude of the triangle from A to BC. So remember, an altitude comes from a vertex. It goes to the opposite side at 90 degrees. Call the point of intersection D. Therefore, the measure of angle BAD, well, if the whole angle was 60 and it's an equilateral triangle, therefore this altitude that we just drew is also the angle bisector, the perpendicular bisector. It's all those special segments. Therefore, this little angle equals that little angle, and BAD is 30. So what we have created here is a 30, 60. This is 30, 60, 90 right triangle. Now let's suppose AB is 2. Solve for the remaining parts of triangle BAD. So if this is 2, then this was 2, and this whole thing was 2, right? And we dropped an altitude down, and therefore this is 1, because that altitude cuts it in half. So what we have then is we have one side here. The hypotenuse is 2, so I'm going to say 2 squared equals 1 squared plus AD squared. So 4 equals 1 plus AD squared. So 3 equals AD squared, and we know that AD is the square root of 3. So this right here is the square root of 3. And that is our special right triangle, 30, 60, 90. You need to memorize these numbers right here. All right, I'm just having some issues with my, there. Okay, we'll try that. So you need to know the hypotenuse is 2, the shortest side is 1, and the other leg is radical 3. You can always find that because, of course, the hypotenuse is opposite the 90. The shortest side will always be opposite the 30. So even if you draw a messy triangle, you know whichever angle you choose to be 30, the opposite will be 1. The other leg is radical 3, and the hypotenuse is 2. Find the 6 trig functions for 30 and 60. So we have to actually then find 12 trig functions. So I should have left a little more space, but anyhow, we'll do 30 first. So the sine of a 30-degree angle, which is this top one up here, is 1 over 2, opposite over hypotenuse. The cosine of a 30-degree angle is adjacent over hypotenuse, radical 3 over 2, and the tangent of a 30-degree angle is opposite over adjacent, which is 1 over radical 3. Once you have your sine, cosine, and tangent, you can go through this pretty quick. The cosecant of a 30 is 2. Should have little degree signs. The secant of a 30 is 2 over radical 3. And the cotangent of a 30 is radical 3. Now for 60, we have a sine of 60 is opposite over hypotenuse, so we have radical 3 over 2. The cosine of a 60 is adjacent over hypotenuse, which is 1/2. And then the tangent of a 60 is opposite over adjacent, which is radical 3. All right, cosecant of a 60 is 2 over radical 3. Secant of a 60 is 2, and cotangent of a 60 is 1 over radical 3. Again, you can memorize these. It would be good if you did it. Memorize them. But if you don't, you for sure have to be able to draw our special right triangle. You don't have to start from an equilateral, but you have to be able to draw your 30, 60, 90 triangle and put your numbers in and your angles in. Okay. Oh my. Now, next, we are going to convert each to radians. Memorize. These you have to memorize. Memorize these values and know the 6 trig functions for each. So a 30-degree, just a little review, if I want to transfer this to radians, I would say 180 degrees is over pi over 180, multiply by that. You will get a 30 degree is pi over 6. You need to know that. Pi over 6 and 30. 45, again, you would multiply by the same multiplier, and you would get pi over 4. 60 is pi over 3. 90 is pi over 2. You have to memorize those if you haven't yet. Example 4, find